So in the last lesson, we learned about multiplication properties of exponents, and this time we're going to learn about division properties of exponents, starting with one called the quotient of powers, which, as you can tell from the name, is dividing things that have exponents. So this first problem we have has got two different bases, x and y, with exponents that are being divided. That's what the line in the middle means. And before we try to jump into this problem, let's see if we can figure out what the rule is, what the shortcut is. And let's start off with a really basic one. Let's do something like x to the fourth power over x to the third power. So x to the fourth power means x multiplied by itself 4 times, like that. And x to the third power means x multiplied by itself 3 times. So when we write it out like this, what we need to remember is that anything divided by itself is equal to 1. So x over x is 1. Here's another one. Here's another one. So what we actually have in this problem is 1 times 1 times 1 times x. And 1 times 1 times 1 times x is just x. So x to the fourth divided by x to the third is just x. Let's try it with a different one. Let's do like y to the seventh over y to the second power. So y to the seventh is y times y times y times y. 5, 6, 7. And y squared is y times y. Remembering anything over itself is 1. So this is 1. And this is 1. So we've got 1 times 1 times y times y times y times y times y. We have 5 y's. So this is y to the fifth. And if we look at the original problem and we look at our answer, probably you can see a pattern here. We had exponents of 4 and 3, and our answer had an exponent of 1. Here we had exponents of 7 and 2, and our answer had an exponent of 5. And so by looking at this, we can see that the shortcut, the rule here, is that we're subtracting the exponents. So if I have something raised to a power divided by the same base raised to a different power, the shortcut is that base to the difference of the powers. I just subtract the powers and that gives me my answer. So let's go back to our original problem, x to the seventh, y to the 12th, divided by x to the sixth, y to the third. And so I'm going to look at the x's first. I've got x to the seventh over x to the sixth, and I'm going to subtract those exponents. X to the 7 minus 6 power is just x to the first, or x. And then I'm going to look at the y's. Y to the 12th power and y to the third power is going to be y to the 12 minus 3 power, which is y to the ninth. So this problem simplifies to x, y to the ninth. And that's our solution, x, y to the ninth. Just subtract the exponents. Okay, let's try one more. Let's do a cubed b to the ninth over a b squared. And again, we can only do this with things that have the same base. So we're going to start off by looking at things that have a base of a. So a cubed over a, this is exponent of 3 on top and 1 on the bottom. So we do 3 minus 1, which is 2. So a squared. And then we'll do the same thing with the b's. B to the ninth over b squared is going to be b to the 9 minus 2 is 7, so b to the 7th power. And there's our solution. And that is the quotient of powers property, which just says if you are dividing two things that have the same base, the way that you combine them is you take the exponent of the numerator and subtract the exponent of the denominator.